All right, so this is it was supposed to be an H homework 3.1, number 5, and it is f of x equals 4 over x squared, and we want to find f prime of 5, and we have a couple of options here. Remember, there's two versions of the formula for finding derivative at a point or derivative of a function. So one of them is the, I'll just write them both down, and I'm leaning toward the alternate formula, but if anybody has a request, I'll gladly entertain your request. So we let h go to 0 of f of x plus h minus f of x all over h. The alternative formula, which will lead to the same result, is the limit as x approaches 5 in this case, and I should put 5s here, here, here. There we go. Stuck in yesterday's mode, and this one would be f of x minus f of 5 divided by x minus 5. So those are the two options on how to do this. And I'm leaning toward the green one today to do something different, and I just have a slight hunch in the back of my brain that that one might be slightly simpler by a step or two. Suggestions: the traditional or the alternative. Yeah, alternative and traditional. Okay. Oh, but the traditional was tripping you up. Okay, we could do both. That's all right. Alternative. All right, I'm excited about the alternative today. So new page. So again, I've got f of x equals 4 over x squared. I want to find f prime of 5, and I'm going to use the alternative approach. So the limit as x goes to 5 of f of x, so that's just 4 over x squared, minus f of 5, which is just 4 over 5 squared. And sometimes this one is a bit easier because we don't have to worry about dealing with that x plus h. And that's all over x minus 5. All right, so here's our change in y. Down here is our change in x. And then we want to see what happens as x approaches 5. Now, generally, if you try to cheat immediately and plug in the value the limit is approaching, you're going to get 0 over 0. And that's what's going to happen here. So I'm not even going to try that. What I'm going to do is just do algebra here. We have another guest. We got Sage. Good morning, Sage. Welcome. This is homework 3.1, number 5. All right, so I guess we're going to go for finding a common denominator. And so I guess of the numerator, the lowest common denominator is going to be x squared times 5 squared, so 25x squared. So I'm going to then multiply top and bottom here by 25, and I'm going to multiply top and bottom here by x squared, and see what happens. And I'm going to skip the whole limit thing for a second and just focus on the algebra here. So that's going to give me 25 times 4. So I'm going to have, switch colors, 100 minus 4x squared over 25x squared in the top. And then that right here is the difference of two squares. So I can rewrite that right there. So that's going to be 10 minus 2x times 10 plus 2x all over 25x squared. And interesting here, let's use green, there's a common factor of 2 in each of these, so I could factor that out. So again, I'm just focusing on this numerator here. So factoring this again, I'm factoring a 2 out of there and a 2 out of here. And so that's going to give me 5 minus x times 5 plus x all over 25x squared. And there's lots of algebraic roots to get that from here to here. That's just the one I ended up with. And ooh, that's beautiful. Check it out. because we have a 5 minus x, which is the opposite of x minus 5. So we're going to get some cancellation going on. All right, new page. All right, so what I have now, I believe, is the limit as x goes to 5 of 4 times x, 5 minus x times 5 plus x all over 25 x squared. And instead of dividing by x minus 5, I'm going to multiply by the reciprocal of x minus 5. Right? With fraction division, we multiply by the reciprocal. And then the note I just made is that this right here is the opposite of that right there. So this divides into that -1 times. You with me on that, right? When we reverse the order of subtraction, we get the opposite result. So when we divide these two, we're going to get a -1, which is nice because that was the 0 in the denominator. All right, so what do we got? Now we've got the limit as x goes to 5 of -4 times 5 plus x, or let's call it x plus 5 for fun, over 25 x squared. Okay, let's see here. I think we're looking pretty good. I think we're ready to see if the limit will evaluate. So the limit of the top exists, and if we plug in a 5 to check its existence, we're going to get -4 times 5 plus 5 in the top, that exists. In the bottom, that exists too. We're going to get 25 times 5 squared. And so let's clean this up a little bit. What does that give us? -4 times 10 over 25 times 25. And we can reduce that a bit by dividing a 5 out of there and out of there. So it looks like I get -8 over 125. And so now we need to check to see if that happens. So we think that f prime of 5 is that when f of x is equal to 4 over x squared. And really the only way to check that this is the case is to graph the tangent line here. So the point that we're interested in is 5, and then we plug in 5, which gives us 4 over 25. And we think the slope m at that point is -8 over 125. So the tangent line should be y minus 4 over 25 equals -8 over 125 times x minus 5, right? The point slope form. So I'm just going to whip out GeoGebra or Desmos and see if that's actually the case. So show desktop, let's get a calculator. Maybe I'm digging GeoGebra. Desmos is wonderful and beautiful and awesome also. Okay, so I want f of x, and again, I recommend function notation when you're using one of these apps because they can do it, 4 over x to the 2nd power. All right, and we are interested at the point, so I'm going to plot that point, and Desmos can do this too, by the way. I haven't tried it yet, 5 comma f of 5, and I know I calculated f of 5, but I'm just going to put it in here too, just to make sure I got it right. So that's this point over here, and yeah, the slope is definitely negative and shallow there, so that seems reasonable, but do we have the right slope? So then we take y minus, and I'm just going to go f of 5 again for the y value, equals the slope we think is -8 over 125 and times x minus 5. And then we just zoom in there. That looks reasonable. And then wheel on the mouse. Otherwise, there's a zoom button here you can play with. And then one cool thing about GeoGebra, if I zoom out a sec, is if I switch to the tools view here and go to the move graphics, I can move the whole thing around, or I can grab an axis and rescale it. So I could zoom in by rescaling the axis, which is pretty cute. That looks pretty darn tangent there, so I'm feeling pretty confident about this, that we get it right. Questions on that fun bit of algebra we did there? All right, no questions in the chat. I hear no audio. Can somebody give me a thumbs up or a nod that we can move on? Good. Okay, cool. All right, cool. Asked for the other way. Awesome. Good job. Thank you. All right, let's do it the other way. So other way, again, initial information, f of x equals 4 over x squared, and we want f prime of 5. So to find f prime of 5, we're going to take the limit as h goes to 0 this time of f of x plus h, and so I'm just going to write that out right here. And so that means I replace x with an x plus h, and you got to use parentheses to do that to be safe. And then minus f of x all over h. And sometimes, like the book, if you look these up in books, they'll do this all at once. And then the alternative, if that's tripping you up, is to do that 4-step process that I recommended before. Like first, calculate this. Second, calculate the difference. Third, try to divide by h, and then finally bring in the limit. So I'm gonna take this in steps. So step 1 up there, 4 over x plus h squared. To square something means multiply it by itself. So that means take x plus h times x plus h. And a lot of people skip this step and do it in their head, which is awesome on homework. Definitely do that. But on a test, the more you write down, the more your brain can look at it and say, did I really do that right? But if you skip those steps, it's hard to look back at what happened in your brain a moment ago. So that's going to give me 4 over x squared plus xh and another xh, so 2xh's plus h squared. And there's really not much more I can do, so now I'm ready for step 2, where I actually bring in that subtraction. So step 2 here, I want to take my 4x squared plus 2xh in the bottom plus h squared, and from that I want to subtract 4 over x squared. And well, usually when we're working with rational functions, we want the factored form of the denominator, which is right here. And here I have an x squared, and they don't have any common factors. So the LCD of these guys right here is just x squared times x plus h squared. And x plus h squared could be viewed as this thing too, or that thing there. We have 3 different versions of it right there. That's the LCD. Yep, not much to do about that. So then what we're going to need to do is multiply that into each of these. So like this one right here, I have to multiply by x squared top and bottom. And this one right here, I have to multiply by that. I'm going to go with the multiplied out version. So I'm going to call it x squared plus 2xh, oops, premature parentheses, plus h squared. And I got to do the same thing in the bottom. The top is the tricky part, not the bottom. I'm going to go for the simpler version in the bottom of the LCD and just leave it that way. So in the denominator, I'm just going to call it x squared times x plus h squared. In the numerator, I have to distribute this -4 here. It has to be distributed to each term there. So then I'm going to get, I have a 4x squared out front here from this one. And then I have a minus 4x squared, a minus 4 times 2xh, so 8xh, and a minus 4h squared. All right, what do we get out of this? Well, we have a number minus itself there, so that's going to go to 0. And then otherwise, we have negative 8xh minus 4h squared, and we can factor a negative 4h out of that. So this way is definitely a bit more work. I'm going to factor out a negative 4h out of the numerator, and that's going to leave me a 2, let's see, x, and what else? A h, right, minus h, is that it? Negative 4h times 2x is negative 8xh. If that's a positive. Negative 4h times h is negative 4h squared. All right, so that's my new numerator, and this is my denominator, x squared, x plus h squared. And nothing cancels anymore, right? I was able to cancel this right here. I was able to do a little factoring in the top, and then I'm done with step 2. Okay, so step 3 is to divide this by h, and the alternative to dividing by h is to multiply by 1 over h. So I'm going to take that and multiply by 1 over h. So I've got negative 4h times 2x plus h over x squared squared x plus h in parentheses squared times 1 over h. And that is nice because the factor of h in the top color cancels with the factor of h in the bottom. So a number divided by itself is 1. And that's cool because I got the 0 out of the denominator, which is always a problem in these. So next, what's left? We have a negative 4. We have a 2x plus h in the top. And please say something if I make an error. I think I'm on the right track here. This is a hard one. You were right to struggle with this, Kelsey. Okay. And I don't see anything else to simplify, but I'm delighted that, right, the 0 is out of the bottom, right? We got that to go away. So we should be able to evaluate this limit. Yep. All right, I'm going to try to write this on a new page because I'm out of room. So now I want the limit as h goes to 0 of negative 4 times 2x plus h, hope my memory serves me well, x squared times x plus h squared. Yep, looks right. And we're evaluating this now as h goes to 0, which I think we can get away with. So again, what's happening with these h's here? Well, they're going to 0, they're disappearing slowly. And if they disappear, we're going to get a, oh, I made a mistake right from the beginning, but that's okay. We're going to get through this. What my brain did somehow is it jumped from section 3.1 to 3.2. And in 3.1, I should have put a 5 here and here, which would have made of this a wee bit easier. But now I'm applying the method from 3.2, which is to leave it as an x. So we'll have to plug in the 5 next. So sorry, Kelsey, I made this a little harder than it should have been in the previous section, but now this is now an example from section 3.2. So here I have an x divided by x, which can divide out. That's going to be a 1, so it looks like the limit here is negative 8, negative 4 times 2, over x squared. And that is what I calculated as f prime of x. I really wanted f prime of 5, which would have been slightly less work. Oh shit, I missed something. Yes, thank you very much. I miscopied that. All right, so we have an error. Let's see, use green. I have an error from here to there. That should have been an x squared. So that should be a square. So that doesn't completely cancel there. So that's going to leave us negative 4 times 2, which is negative 8. This x definitely does cancel, but only with one of those. So the denominator should be x cubed. Cool. Good job catching that. So that right there should be x cubed. All right, so just stare at that again, double check. I got the error. Yep. Yep. Okay, that looks better. So now we get negative 8 over 5 cubed. 5 cubed is 125, which matches what we got before. All right, so sorry that over here I slipped from writing a 5 to writing an x, but this is the technique of section 3.2. See, I'm trying to imagine a 5 in there. Yeah, it would have been just slightly easier, but very similar to what I have here, but with a 5 floating around and a 5 squared. All right, so just to go back a second here, we have two different forms of calculating a derivative from the definition of the derivative. We have this traditional one with the plus h, and sometimes it'll be a delta x instead of an h, and we have this one right here where we have what looks like a more traditional rate of change slope function from college algebra. And sometimes the traditional is easier, and sometimes the alternative is easier, and sometimes they're just about the same amount of work, and you never know until you do them both. So if I'm in a situation where I'm like not sure about my work on this one, then I might try that one and see what happens, see if I can get them both to agree with each other. Otherwise, the only other way to check if a result is right is to take a look graphically and see if we looks like we have an accurate tangent line on the curve. All right, let's try another one. Actually, I want to go back and look at an example from yesterday. So let's see here. I want to look graphically. So let me get a new version. GeoGebra. And the function from yesterday was a quadratic, and it was 2x squared minus 3x plus 7. Yeah, that looks like the right one. Let's just bring that down a little bit. And we found the derivative, I'm going to call that d for derivative, d of x. We found the derivative was 4x minus 3. And an equal sign would help there. All right, so there's the derivative. And we played around with a tangent line, and I talked about that point at the bottom there. And just to check that point on the bottom, my recollection is that it was 3/4 for x, and then the y value is, if I plot the point, f of 3/4. So there's that point at the vertex. And what I was mentioning the other day is that that point on the vertex, on the left side of the curve, we have negative slopes. On the right side of the curve, we have positive slopes. And if the slope goes from negative to positive, it must hit 0 in between. And if we look at the derivative curve here, and it's 0, that 0 happens at positive 3/4. And so kind of checking to make sure I have the right slope function. So this blue graph is the slope function of the red one. Any point on this graph tells me the slope of the green curve at that point. So for example, if I pick at the point 3/4 0 here, that's saying, hey, the curve up here has a slope of 0 when x is 3/4. Down here, for example, when x is 0, the slope should be -3. So at this point over here, the slope of the tangent line at that point should be -3. And so any point I pick on this curve is going to tell me what the slope is. So it looks like this curve has the point 2, 5. And so I should find that at the point over here, when x is 2, the slope is 5. And I can check that real quick by plotting a tangent line there. So let's see, it looks like the green one has the point 2, 9. So I should find there that if I take y minus 9 using the point slope formula equals, the blue one tells me the slope is probably 5 there. So 5 times x minus 2 is the x value. And it looks like that probably is the tangent line. So what we're doing in section 2 is we're taking some given function and we're deriving from that what I'm calling a slope function, which is also called the derivative function. And that derivative function has lots of applications. I looked at one the other day. So let's get that, we got that. Okay, new page. So just a couple notes on a function and a derivative function. So often we call the derivative function f prime of x, and so that's just a little apostrophe up there. And we find that by taking the limit, or at least the traditional way, as h goes to 0 of f of x plus h minus f of x over h. And graphically, again, what we're doing there is I have some function and I have 2 points to play with. So I have a point here, let's call that x, and then I slide that way a little bit, a distance h, which gives me a new value called x plus h. And so that's going to give me a point over here. Each of those has a y value, so this y value is f of x, and this y value is f of x plus h. And what we're trying to do is we're trying to slide this point toward that point. So we're trying to take this secant line, which is this difference quotient here, and slide the second point toward the first point and see if we can identify what the tangent is, the tangent slope. And we're doing that for any x value, not just a single x value. And just some other notation. Sometimes instead of calling this distance, this distance here, instead of calling that h, sometimes we call it delta x, and the delta symbol means change. So that's a change in x. And correspondingly, that generates a change in y. So I'm going to call that delta y right there. And so that's just change in y. So this numerator is the change in y, the denominator is the change in x, and h, color h, is the same thing as delta x. They're interchangeable. They're two ways of talking about that distance there. And we're really zoomed in here, so that's kind of like a microscopic distance. So just slightly different notation. This is saying what's the limit as delta x goes to 0. And the numerator, I'm just going to call that delta y, right? That's just the difference between these two y values, right? This minus that, divided by delta x. And that's delta there. And as delta x goes to 0, we end up with this derivative function. And often in the limit, we call this instead dy dx. So f prime of x, right, the derivative function of the original is often called dy over dx, or sometimes just spoken dy dx. So that's another notation we're going to get used to. And there's different ways of using this notation right here. So another way we'll see that written, and I'm going to use this occasionally, is to write d over dx like that. And this says, the way to read this right here, this whole thing here, is the derivative with respect to x. And we have to take a derivative of something, and so what will often appear next to this is a square bracket and then the function. And this whole thing right here is really the same as this thing up here, because f of x is y. And so you'll see different notation. I'll write it sometimes, it'll be in the book sometimes, homework problems, videos. People will go back and forth between doing something like f prime or dy dx or the derivative of some function. So for example, if we go back to that problem we were just working on, where we had f of x was equal to 4 over x squared, if we're asked to find the derivative, shorthand, it could be just like, we might just say, what is f prime of x? But we would have to be given that right there. Another thing I could write is that means the same thing as all of this condensed into one piece of notation is take the derivative with respect to x of 4 over x squared. And at this point in time, for us, that means use the definition, which is the traditional or the alternative formula. So all of this up here means the same thing as this blue notation down here. So that's going to pop up. Okay, so let's go a little bit further with this. I'm going to start a new